When you see the notation k times f of x, you should be thinking the f of x is my y values or my outputs. So when I multiply the y values by something, that's going to change their height on the graph. If we multiply by a number bigger than 1, it's going to pull or stretch all of the y values up higher. If we multiply by a decimal, it's going to compress all of our y values down. In your note sheet there, we'll write this notation, k times f of x does one of two things. Does a vertical stretch if your k value is bigger than 1, and it does a vertical compression if your k value is between 0 and 1. Here's a quick example of this. I've got a t-chart for the mother function square root of x, and then I've taken my t-chart and multiplied all the y values by 3, or in other words, I've made the function become 3 square root of x. Look at those y values 3 times as big, and then when we look at the graph, we can see, there's the mother function in bold, and then the curve has been stretched vertically. It's been pulled up. I just changed my second function to be 0.3 times the square root of x, and now when we look at the graph, we can see the mother function has been compressed or pushed down towards the x-axis. I've just changed to a new function here. I've replaced the 3 to put it in with the x, so it's now f of 3x, which using square root of x as our mother function would be the square root of 3x. So now look at this t-chart and notice the two y values that are both 6. In the mother function, it took us a time or an x value of 36 paces to get to 6 height. But now, with the square root of 3x, it only took us a distance of 12 to get to that same height. So our graph has been compressed horizontally. So this notation, f of k times x, changes our graph, dilates it horizontally. It does a horizontal compression, as we just found out, if k is bigger than 1, and it does a horizontal stretch if k is between 0 and 1, aka a decimal. Here's f of x and f of 3x. When we look at the graph of these, if you can picture me pushing from the right onto the mother function, how that new function how it would bubble up. And likewise, here's f of x and f of 0.3x. Picture that f of x, that bold function, to be like a piece of string, and if I were to pull on it to the right, it would flatten out, or we would stretch it out.